Good afternoon, everybody. We're going to go ahead and start by teaching you the very basics on exponential functions and how to identify them and how to graph them. So we'll start with the basic form first of what an exponential function looks like. It looks like this. We've got f of x equals a b to the x power. Now, if you notice, this is a little different than what we've been dealing with before because our variable, our x, is up as an exponent. X is now the exponent, thus it's an exponential function. Now there are two types of exponential functions that we deal with. First type is what we call a growth function, and the second type is a decay function. Now, but basically a growth function is going to grow, and a decay function is going to, or increase, and a decay function is going to decrease here. Now, we should be able to look at the equation itself and tell just by looking at it if it's a growth function or a decay function. And that's by looking at this letter right here, this b. If that b is greater than 1, then we know it's going to be a growth function. If it's between 0 and 1, it's going to be a decay function. Now, if you notice, we don't ever talk about it being negative. That b has to be a value that is greater than 0. Now, the a value, the value sitting up front here, can be a negative, but that b has to be greater than 1. So let's give you a couple examples, and let's go through these and identify these as growth or decay. So let's start up here with the first one. F of x equals 4 times 3/8 to the x power. So we want to look at this function part right here. That is our b. And we know that that value is less than 1. So this is going to be a decay function, or it's going to be a decreasing function. Now if we look at number 2, that is our b. We know it's greater than 1. Therefore, this is going to be a growth function. Okay, now sometimes they can get a little trickier. Let's look at this. So if we notice, okay, initially that's 7. Okay, 7 is definitely greater than 1, but this, so it looks like it'd be a growth function, but if you notice, we have got a negative right here. Okay, so you have to remember, what do the negative exponents do? The negative exponents change that base. So this is going to become 8 times 1 over 7 to the x power. Now, we look at it like this, 1 over 7, well, that's definitely something that is less than 1. So this is going to become a decay function. So we have to look for those negatives. So let's look at 4. Here again, we've got that negative there. So that means it's going to change the base. So it's going to be f of x equals 5 times 8 to the x power. And that b is greater than 1, so this is a growth function. 2 more that we want to look at here. Ooh, okay, so now I'm looking at this one, and this is a decimal. Well, that's, we can handle that, but it also is not only is a decimal, it has a negative sign. All right, so we're going to have to really walk through this. Let's think. How can we put that decimal as a fraction? Well, I know that 0.25 is really 1/4. And then we've got to the negative x. And then what's that negative x do? It's going to flip it. All right, so now I've got a clearer look at what the actual value of b is. And we know that b is 4. Therefore, this is a growth function. All right, one more let's look at here. Ooh, this is a fraction. But let's see, 4 over 3. 4 over 3, we got to think. Is 4 over 3 going to be greater than 1 or less than 1? Well, that's greater than 1. And then let's check for the negative up in the exponent. It's not there. So this is a growth function. So you can see it's not real super difficult here to determine which way we're doing, if it's a growth or decay, but it does take a little bit of us practicing and seeing what we've got.